Uh, all right. Is light a wave or is it a particle? Now, I remember as a kid, I always thought that light was a bunch of waves. That was a very distinct thought that I had because I wondered, what the sun was as a kid. So I looked it up and I found out a big ball of gas that's energy radiates out, and I was like, "Oh, okay." But eventually, I found out that there are shrimp that can see more colors than us. And as you can see in the background, I have the mantis shrimp, and that is the shrimp that can see more colors. So I looked into it and I tried to figure out where these colors are and why I can't see them. And as I looked into it, I got more and more certainty that light was indeed a wave, and that these shrimp were able to see a wider spectrum of the light that's emitted, and that humans aren't able to see the entire visible light spectrum, which hadn't really occurred to me. Now, I thought about it, and eventually one of my parents compared it to radio waves, and how radio waves are the only kind of waves that get picked up by the receivers that we have in our cars, but they don't pick up all waves, they don't pick up X rays, and humans would have their eyes as receivers in this analogy, and we just are not programmed to pick up the entire spectrum of light. But eventually, I learned that light has the properties of a wave for sure. It refracts, it shifts, it has a frequency and an amplitude, and it exhibits the behavior of waves. Now, on the other hand, we have the idea that light is made up of photons, and it is clear that it's made up of something. Einstein actually was one of the people to discover that the frequency of a wave changes the energy a single photon has, which means that waves, that light is also a particle. And Einstein won a new Nobel Prize for that. Um, Now, in addition, the double slit experiment has a constant beam of light that's shot through two slits into photo paper, and it's clearly made up of individual small parts. And these small parts have a distribution on the photo paper. And in that distribution, as you can see right here, it looks like a almost like a bell curve where it's the most intense and it gets less intense as it goes out, mirroring this wave behavior, even though we can see from Einstein's explanation that one dot go in, one dot go out, three dot go in, three dot go out. It is not a constant wave, it is a action of particles going through something. So that brings us to the question, is light a wave? Is light a particle? I mean, if you were to show someone a can of beans and hold it directly circular face at them, they would tell you it's a circle. But if you were to hold it straight up, they would tell you that it's a rectangle. When in reality, it's something entirely different. So, is light a wave? Is light a particle? I think both. But I also think that there is a definite possibility of light being something entirely different that exhibits the properties of a wave and the properties of a particle, which we have seen. Now, I don't know for certain, but that is my thoughts on the matter, on the wave versus particle debate. I'm unsure. I will say, for now, in conclusion, that it is both, though. All right. I hope everyone has a great day and that they enjoy the rest of their summer. Thank you and goodbye.